White holes are theoretical cosmic regions that function in the opposite way to black holes. A white hole's event horizon is a border of no admittance point space that is most of the time an exclusive club. No outside event will ever have an effect on the inside energy. It is considered a region of spacetime and uniqueness that cannot be entered from the outside, although energy matter, light and information can escape from it. This white hole is even more rare than a black hole, and its properties are almost the exact opposite of a black hole. It is the reverse of a black hole, which can be entered only from the outside and from which energy matter, light and information cannot escape. White holes appear in the theory of eternal black holes. This region does not exist for black holes that have formed through collapse. If the two were to collide, the white hole would enter the black hole, becoming part of it from an outside perspective. There are many physical processes through which a white hole could be formed. Colossal black holes are predicted to be at the center of every galaxy, and that possibly, a galaxy cannot form without one. The possibility of the existence of white holes was put forward by Russian cosmologist Igor Novikov in 1964. A century ago, Albert Einstein predicted the existence of black holes, points in space where gravity is so strong that neither particles nor light can escape from them. Stephen Hawking and others have proposed that these supermassive black holes spawn a supermassive white hole. Stephen Hawking worked on the physics of black holes. He proposed that black holes would emit subatomic particles until they eventually exploded. Like black holes, white holes have properties like mass, charge, and angular momentum. Objects falling towards a white hole would never actually reach the white hole's event horizon. The white hole event horizon in the past becomes a black hole event horizon in the future, so any object falling towards it will eventually reach the black hole horizon. Imagine a gravitational field without a surface. Acceleration due to gravity is the greatest on the surface of any body. Where do black holes come from? Black holes were formed in the early universe soon after the Big Bang. Stellar black holes form when the center of a very massive star collapses. This collapse also causes an exploding star that blasts part of the star into space. Since black holes lack a surface, acceleration due to gravity increases substantially, but never reaches a final value as there is no considered surface in a singularity. A white hole is a region in which spacetime flows unbending outwards. It is believed to have an event horizon radius which restricts the entry of any matter including light. White holes are created when astrophysicists explore the environment around black holes. But pretend there's no mass within the event horizon. White holes are completely theoretical mathematical concepts. They're not things that actually exist. It's not like astronomers detected an unusual outburst of radiation and then developed academic white hole models to explain them. If white holes did exist, they would behave like reverse black holes, just like the math predicts. Instead of pulling material inward, a white hole would blast material out into space. One of the other implications of white hole math is that they only theoretically exist as long as there isn't a single speck of matter within the event horizon. As soon as a single atom of hydrogen drifts into the region, the whole thing would collapse. Even if white holes were created back at the beginning of the universe, they would have collapsed long ago, since our universe is already filled with stray matter. White holes are returning to the experimental spotlight. White holes were long thought to be a figment of general relativity born from the same equations as black holes. A white hole has mass. It might spin. A ring of dust and gas could gather around the event horizon, the bubble boundary separating the object from the rest of the universe. While a black hole's event horizon is a sphere of no return, a white hole's event horizon is a boundary of no admission. No spacecraft will ever reach the region's edge. Objects inside a white hole can leave and interact with the outside world, but since nothing can get in, the interior is cut off from the universe's past. No outside event will ever affect the inside. Black holes, the most famous singularities, are regions of space so warped that no exits exist. The outside universe can influence the inside of a black hole's horizon, but the interior can't affect the exterior. It is believed that black holes and white holes are mirror images of each other. They are diametrically opposed to one another. A black hole has an event horizon beyond which you can never escape, whereas a white hole has an event horizon beyond which you can never even get close. Physicists define a white hole as a black hole's time reversal, or a movie of a black hole played backwards. In the same way that a bouncing ball is the inverse reaction to a falling ball. Another theory holds that objects within a white hole can leave and interact with the outside world. But nothing can enter because the interior is cut off from the history of the observable universe.